Capillary action stops when the weight of the liquid in the tube is equal to the adhesive forces pulling the liquid into the tube. Everybody knows that some things float in liquids and some things don't. The property that causes things to float is buoyancy, or buoyant force. An object placed in a liquid always displaces some of the liquid. The weight of the liquid displaced is equal to the amount of buoyant force pushing up on the object. A floating object displaces an amount of liquid whose weight is exactly equal to the object's weight. A sinking object displaces an amount of liquid whose weight is less than the object's weight. With liquids, two other properties you need to be familiar with are specific gravity and density. The two are closely related, so we'll consider them together. Liquids don't have definite shapes, but they do have definite volumes. Knowing the volume of a liquid can help you to figure out its density. Specifically, the density of a liquid is its mass divided by its volume. Mass is normally expressed in terms of weight. For example, a cubic foot of water weighs about 62.4 pounds, so the density of water is 62.4 pounds per cubic foot. You can also calculate the density of a liquid if you know its specific gravity. Specific gravity is commonly used to measure the concentrations of solutions, such as acids. This measurement can be made with a hydrometer. You've probably seen one that checks the battery acid in your car. The specific gravity of a liquid is the weight of a volume of the liquid divided by the weight of the same volume of water. Water is used as a standard because it's the most common liquid. It's given a specific gravity of 1. To take an example, the specific gravity of sulfuric acid is about 1.8. So sulfuric acid weighs about 1.8 times as much as water. If the specific gravity of sulfuric acid is 1.8, then sulfuric acid weighs 1.8 times as much as water. This also means that sulfuric acid is 1.8 times as dense as water. Therefore, you can calculate the density of sulfuric acid by multiplying 1.8 times the density of water, which is 62.4 pounds per cubic foot. Sulfuric acid has a density of about 112.3 pounds per cubic foot. Many fluids and process systems are in a liquid state. The temperatures and pressures at which systems operate can have important effects on liquids. In liquids, there are cohesive forces between the molecules, but these forces are fairly weak. As a result, the molecules can move around freely. Temperature changes affect this molecular motion. When a liquid is heated, the molecular motion increases. At a high enough temperature, the forces holding the molecules together are overcome. Then some of the molecules separate from the liquid and are released as a gas. In the case of water, this is the point at which the water boils into steam. When the temperature of a liquid is decreased, the molecular motion slows down. At the freezing point, the molecules form a solid crystal structure, such as ice. So one of the most important effects of temperature on liquids is the possible change in the state or phase of matter. If the temperature is increased, a liquid can be changed into a gas. If the temperature is decreased, a liquid can be changed into a solid. Let's turn now from temperature to pressure. By definition, pressure is force applied over an area. In an open container, pressure is affected primarily by the weight of the liquid applied over a given area. These circles represent liquid molecules. If we focus on the bottom of the container, the pressure exerted there is the total weight of the liquid divided by the area of the container's bottom. The pressure exerted on the side of the container is a result of the force of the liquid pushing outward. The force pushing outward is a result of the weight of the molecules above. This means that the pressure in a liquid varies with its height or depth. As we move upward, there are fewer molecules of liquid above. As a result, the pressure in a liquid is greater the deeper you go in the liquid. As the level decreases, the pressure at the bottom decreases. As the level increases, the pressure increases. In this topic, we looked at many of the important physical properties associated with liquids. We also saw some of the main effects of temperature and pressure on liquids. Now's a good time to review your understanding of the material by trying a couple of practice questions. Lubricating oils are often cooled in lube oil coolers to maintain their viscosity and lubricating ability. If lube oil is overheated, its viscosity and lubricating ability are decreased. As a result, it may not adequately lubricate bearings or other components. This means that the pressure in a liquid varies with its height or depth. As we move upward, there are fewer molecules of liquid above. As a result, the pressure in a liquid is greater the deeper you go in the liquid. In this topic, we looked at many of the important physical properties associated with liquids. We also saw some of the main effects of temperature and pressure on liquids.